welcome to Lecture 17, Robot Autonomy and Human-Robot Collaboration. Autonomy is our final essential condition for robots. As with some of the others, it is challenging to draw a hard line between devices that are and aren't autonomous. Even if we were hardliners, there would be ambiguity. Does autonomy include independence of human influence in all things? Consider the following aspects of robot behavior, considered as the behavior of a group or an individual robot. Who? The choice of robot or robots acting. What? The action itself. When? The timing. Where? The location. Why? The goal. And how? The method. Any of these 6 aspects could be autonomous, but it seems too strong to require all these to be autonomous. After all, isn't one of our motivations for making robots having some influence on them? And there are more considerations, such as the programming, construction, and even design of the robot. Perhaps the only fully autonomous robot is an ideal robot approached in an evolutionary process of alive, a la artificial life, robots. Our perspective is that if any of the above considerations is autonomous, that is sufficient to satisfy the condition of robot autonomy. It turns out we would like to inhabit the same spaces as robots. In fact, one of our primary motivations for building robots is to have them help us. If you've ever been helped by someone over whom you have no influence, you'll start to see the trouble with fully autonomous robots. What has proven more valuable in virtually every field of robotics is work that contributes to the better integration of human and robot activities. A way to consider the breadth of this field is to give it 2 categories. 1, human-robot interaction, which is the broad and interdisciplinary study of the interaction of robots with humans, including communication, socialization, and design. And the second category, sometimes considered a subcategory of human-robot interaction, is human-robot collaboration, or HRC, which is the study of human-robot teams working together to achieve goals. We will here explore human-robot collaboration, or HRC, in more detail. It has been observed that what is hard for a human is easy for a robot, and what is easy for a human is hard for a robot. This is often understood as a challenge to human-robot interaction. Humans tend to expect robots to be able to perform tasks simple to humans easily. So robots frequently seem downright inept. However, we can also turn this observation around. Humans and robots are actually complementary. The problem, then, is to find ways for robots to work collaboratively with humans, not necessarily replace them. There are, of course, several challenges, most of which have been revealed by attempts to design, build, and deploy collaborative robots. Other challenges were predicted by studying human collaboration to discern some essential qualities of collaboration that will likely remain true in successful human-robot collaboration. Before we consider some important details that have emerged from these studies, it is worth noting that since humans find collaboration with humans on many tasks like moving furniture simple, we should expect that robots won't. And this turns out to be very much true. So here are some requirements that have emerged for collaboration in teams. Okay? A shared goal or goals. Collaboration requires team members share a common goal. Commitment. Collaboration requires members of the team to be committed to the achievement of the common goal. Knowledge. Collaboration requires members of a team to internally represent knowledge of the states of the environment. Sensitivity. Collaboration requires team members to be sensitive to the environment, each other, and themselves. Communication. Collaboration requires team members to be able to communicate effectively, updating each other about the states of the environment and themselves. And finally, planning. Collaboration requires team members to be able to plan, that is, to reason through which actions are required to achieve a common goal. Relatively simple models of practical reasoning, for example, the belief, desire, intention, or BDI model, described by Mueller in that paper I referenced, and relatively detailed cognitive architectures, for example, SOAR, have been used to better design robots that can better collaborate with humans. Several robot control architectures have been developed with insights gained from this work. We will review some important examples in Chapter 2. All right, that's all I've got for you for today. Take care. Thanks.